Today we're doing lesson 35. And lesson 35 is the change in coordinates. Change in coordinates. And to find the change in coordinates, we are going to use this little idea of when I go from one place to another, it's pretty much the same as if I started on the other end and came this way, right? So school to home or home to school, for the most part, you're thinking that's the same thing. It's the same distance, but actually it's slightly different because of the direction you're going. And so there's going to be a slight difference if I move from one point to another or from that point back to the original spot. And so the way to avoid the confusion on that, we always do final minus initial. So if you always do final minus initial, you will be fine. Now, when we talk about minus initial, sometimes that distance will be positive, sometimes that distance is negative, and that's according to the direction that you are moving. So if I had 2 points here, going in this direction, you'd have a positive direction if it was an xy point. If we were going in the opposite direction, as in going down from one point to the other, you would have a negative because the numbers are getting smaller. Okay? And so, what are we looking at? We could call, if we wanted to, we could do this as point 1, and this one is point 2. And if I am traveling from point 1 to point 2, it'll look different from point 2 to point 1. So, what would it look like from P1 to P2? There's a difference in their coordinates. The x coordinates and the y coordinates. Now, this is not something we're going to stick together. We're going to keep them separated, as in the x coordinates are separate from their y coordinates. And so, if we said we had point 1 and point 2, we'd probably also say that that would be x1, y1, correct? And point 2 would be x2, y2. That's how we designate x. We use the same variable for x's, we just use subscripts. And so what would it mean now if I ask, hey, what if I'm going from point 1 to point 2? What would the change in x coordinates look like? Well, the change in x, or sometimes we use delta x, right? The change in x, that's a delta, the triangle. That's a change in x. What would it look like? Well, what's the final point? It's point 2. And point 2 was x2, and you subtract your initial x1. That is the change in x from point 1 to 2. How would that be different if I went from point 2 to point 1? There's a difference in the fact that your final is now point 1, so it would be x1 minus x2. And according to whatever those x values are, one of these will be positive, one of them will be negative because of a direction. The same thing applies for the y's. That'd be y2 minus y1, that's x, sorry, y1, and y1 minus y2. So the same thing applies if I want to talk about the change in y's. So what kind of problems are they going to ask you? Well, they're going to ask you things like this. If P1 is negative 3, 2, and P2 is -4, -5. What is represented by this? What is represented by -3 minus a -4?
Change in x.
Okay, Ben says a change in x. There's more to it. Is he correct, though?
Yeah.
Those are the x's. Those are the x values. So, okay, it's going to be a change in x. Hopefully we all saw that. So it's a change in x from where? The question is what point to what point? Is it P1 to P2 or P2 to P1? Where is -3? -3 is in P1. It's always final minus initial. So my initial, if -3 is P1, that was my final, and 4 comes from P2, that's my initial. So then I'm actually going from P2 to P1. That's what you'd have to write. Change in x from P2 to P1. Yes?
How'd you ever put the -3 instead of -45?
The next one I want you to figure out is -5 minus 2. What is this to change in? Okay, -5 and 2 look like they come from the y's. So we're going to call that the change in y. From 5 comes from, the -5 comes from P2. That must be my final. 2 comes from P1. So we are actually going from P1 to P2. Does that make sense of what we're doing there?
Is P2 always the final?
Not always the final, because obviously in the first problem it wasn't. We actually went from P1 to P2. Okay, so let's just see if you guys got the idea. P1 of -3, -2 this time.
Wait, is this a new problem now?
Just another example. Okay, here's P1 and P2. They look almost identical to the last ones, but they're slightly different. Tell me, what is the change going on here? What kind of change is going on? Try that one. And before you answer, try this one as well. So, part A, what is it? X's or Y's? Okay, so it's a change in X. From? P1 to P2. Final minus initial, so yes, P1 to P2. What about the second one?
Change in y is P2 P1.
Change in Y from
P2 to P1.
P2 to P1. So has everybody got the idea on what we're looking for here? We are looking for which coordinate it is, and we know that by looking at the numbers 2 and -5. -2 and -5 are my y coordinates, so that's why we're changing in y's. And then you look at it's always final minus initial. And so, final minus initial. And therefore, you know you're going from the final point, which is -2, which is in point 1, should it also be then initial to final. Because you're traveling from your initial spot to your final destination. You end up in a final destination. That's where you end. Okay, I don't know if that helps kind of clarify which point is going first. It's always kind of it's always the reverse. Okay, from what the final minus the initial.
Is it always, or is it just
It's always that way. We set it up as final minus initial.
Yeah, I was just making sure, 'cause that's how I'm doing it, I'm just looking at it and switching it.
Okay. The point of all of this, as a great transition, is part B. Part B asks us the name of a number. Whoops. The name of a number. The book has some weird names for some of this stuff. Basically, they're saying that a number is equal to the initial plus some fraction times its change in C. Changing coordinates. Delta C, changing coordinates. That is a plus.
Wait, so what's the bond? What's the left rest of that say?
So it's a number equals the initial plus some fraction or percentage of the changing coordinates. The changing coordinates are the things we just dealt with. The x1 minus x2 or x2 minus x1. Okay? So what we're going to ask you to do or say is, what is the number whose graph is 2/3 of the way from, here's our problem, 2 to -7. That's a question mark, sorry. What is a number whose graph is 2/3 of the way from 3 to -7? So what you realize here is that you're starting where? 3. And I'm moving to where?
-7.
So if I was to draw some kind of graph on this, here's 3, here's -7, and I'm traveling in that direction. So my answer, because it's 2/3 of the way there, is most likely going to be negative. You're going to be on the negative side. So it's good to kind of notice that and see that. But you basically want to know is, you're only going to travel 2/3 of the way there. You're not traveling all the way. You're going to end up somewhere in the middle, right? Probably a little bit further along. And so what you need to do is, you need to find that difference, or that change. You need to multiply it by its fraction, and then add it to the beginning, which was 3. You started at 3. That's where the equation comes into play. I'm going to take my number, which I don't know what it is, so I'm going to leave it as n equals, what's my initial number? 3. Plus the fraction is 2/3. And this is where I do my difference, or my change. And the change is always final minus initial. What's my final number? -7 minus 3. And if I do that, I end up with 3 plus 2/3 times -10, which equals 3 plus -20/3. Can you guys agree with that? I don't have a common denominator. What the common denominator between these two would be? 3. And so I'm going to change the color here. And so I'd have to do 3/3, yes? And 3 times 3 is?
9.
So it'll be 9 plus a -20 all over 3, which ends up being?
Yes. That would be -11. So that would be 3 and
So
-2/3.
-11/3. I know it's in the stamp there of the dictionary, but that's your answer. So what does that mean? We could convert that. If we converted that, it would be -3 3 2/3. So if I went back to my number line, if this was at 0, it'd be somewhere about where we had it.
I agree.
A little bit more than halfway from 0 to -7. Okay? It's not asking you to graph it, it's just asking you to find the number. And so, let's find another one. What is the number? Gotta scroll here. What is the number that is 3/7 of the way from -4 to 9? What is the number that is 3/7 of the way from -4 to 9?
Wow.
So, what do we use? N equals
-4.
initial plus the fraction of the
later one.
final minus initial. Maybe I'll put FR for fraction. Is basically what we're using. So N is equal to, what's my initial number?
-4.
-4. No, wait a minute. If I'm moving from -4 to 9, I am actually going in which direction? Positive direction. Okay. Plus 3/7 of
9 plus 4.
9 minus a -4, which ends up being plus 4. 9 plus 4 is 13. So we end up equaling -4 plus 3/7 times 13. And so what's 3 times 13?
39.
So this is plus 39/7. And I got to get a common denominator, and that would be?
28.
It'd be 7s. So it'd be 7/7, which is -28/7 plus 39/7. I'm not sure. And if you add those together, you end up with? Oh, it's not negative. It's 11 over 7. And if you were to work that out, you would say, oh, that's 1 4/7. So a little bit more than 1.5. So we are actually got to the positive side. Okay? So are there any questions on that?
No.
The last one is, the last thing we got to talk about is the distance formula, guys. The distance formula is just the change in x and the y's put together in a way that works. If I call this one x1, x2, not x2, sorry, y1, and I call this one x2, y2, and I wanted to find the distance between those 2 points, I would have to say it's a straight line, yes? Shortest distance between 2 points is a straight line. And if I asked you to find that distance, one option we could do is draw in a right triangle and use Pythagorean's theorem, right? And so I want to know D, the distance. Here's the cool thing, is that if I take this distance, what would be the distance of this line?
The change in y.
It'd be the change in y's, which would be say, hey, if I start on the bottom and move to the top, we'd be like, oh, that's y2 minus y1, yes? On the bottom, if I go the other way, I start at x1 and I go all the way to x2 because this would be x2, y1 as a point, right? This distance down here becomes x2 minus x1. That's this distance. We can call this A, and can we call that B? So in our case, because of the variables we're using D. Would you guys agree that D is equal to A squared plus B squared? Or that's D squared, sorry, right?
Yeah.
So wait a minute. I know what A is, and I know what B is. So wouldn't D squared equal x2 minus x1 squared? Plus y2 minus y1 squared? Can you guys agree with that? Then, to solve for D, I would take the square root. Guys, that right there, right here, is the distance formula.
Whoa.
The distance formula is, whoops,
Why is it yellow?
because I highlighted it. The distance formula, a little bit more cleaned up here, would be D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now we're just using the distance formula. If I gave you 2 points, could you find the distance?
Yeah.
So if I gave you points like, okay, here are the points, 4, -2, and xy. Uh-oh.
Don't go there.
What is the distance?
Action.
So if I gave you points, you just plug them in, that's okay. That's probably what we've done already. Now, I'm taking away one of those points and calling it x and y. Here's the thing. It doesn't matter which one you call point 1 and point 2 because eventually you're subtracting and squaring. And the squaring will take away all signs. It makes them all positive. So, why don't I say that this is point 1 and this one is point 2? Is that okay? And so D equals the square root of x minus 4 squared plus y minus 2 squared, which end up being plus. You've got it. You're done.
Wait, that's all we have to do?
That's all you have to do. You found the distance. Here's the cool thing. You just built a formula that says if I gave you x or y, you would be able to find D. In a way. So you don't. You'd stop here.
But what about the
Square root's on it already.
like, can you cancel because of
Your homework is lesson 35, page 253, 4 through 8, 12, 15 through 17.